Hello, my name is Jakub Bijak from the University of Southampton, and it's my pleasure to present a talk about mixed frequency vector autoregressive or VAR models as a new approach to predicting and analyzing future migration in Europe with the help of macroeconomic data. This is a piece of work that was done as part of the QuantMIG project and is currently extended in yet another European project, Future Resilience of Europe, and has been led by my colleague Emily Barker, also from the University of Southampton. So the motivation of this talk is the constatation that we have already some methods for dealing with anticipatory migration scenarios across a range of time horizons, from early warnings and change point detections in the very short time scales to time series models in the horizon of a few years ahead, to scenarios for longer range futures. And this work will look at both the forecasting and scenario making aspects of the anticipation of migration. So we will be using formal econometric and statistical models, vector autoregressions, but we will be using them in two different contexts. And the background for that work is the studies on using vector autoregressive models for forecasting migrations, two examples of which include the 1999 pioneering work by Gorby, James and Pote for New Zealand, as well as the work by truly for a few flows of migration within Europe. The key challenges identified in those studies included, first, rather high uncertainty of the predictions, especially for European flows, partly due to the shortness of the time series available. The uncertainty of the forecasts was very high. And of course, the uncertainty was compounded by the fact that within such models as vector autoregressions, it's not only migration is being predicted, but also all the different variables that covary together with it. So what are vector autoregressive models? As in autoregressive models, we are regressing the present state of a variable, so migration and its possible covariates, on the past values. So we are, in this case, by doing this jointly for a vector of a few variables together, we are able to predict our variables simultaneously. The panel VARs, thanks to the panel construction, enable additionally borrowing of strength between the units of observation. So we can fit panel vector autoregressive models for a few countries at the same time, with the hope that thanks to some shared characteristics in terms of the migration or macroeconomic patterns, we will be able to borrow information about the statistical properties of the behavior of these processes. So these are quite important advantages potential advantages of using VAR models in predicting migration. But at the same time, typically for migration, we have rather short series of data. The data are typically annual, which in fact pose a serious limitation on what can be usefully said about the future. So the challenge is, how can we utilize all the data that are available to us, some of which may come at other frequencies, so be more frequent than annual, and how can we put the best use of this information, also borrowing strength from other countries or information about other migration flows in order potentially to strengthen the forecasts. And the possible solution is in actually trying to run multiple frequency vector autoregressive models and panel VAR models, ideally together, or as we will present in this talk, at least sequentially. So in this exercise, what we'll be presenting is forecasting with vector autoregressive models, forecasting of migration with vector autoregressive models, which aims at producing forecasts of migration flows with some uncertainty assessment. And we will also use these models to assess the different effects of migration. So the end game is to try to see how resilient the whole macroeconomic systems may be to rapid changes in migration. But the framework is much more general. So we will be using empirical vector autoregressive models also, not only as forecasting tools, but also as a vehicle for setting migration and macroeconomic scenarios. So the data we'll be using come from the quantum migration estimates. This is a source that has been produced also as a part of the quantum project and includes harmonized estimates of migration for Europe between 2002 and 2019. The economic data come from national accounts, fiscal accounts, and the labor force survey. And whereas migration data typically come in annual frequency, and quantum migration estimates are no exception, the economic data are quarterly. So we have a clear example of a mixed frequency situation. So the methodological approach will consist in first estimating mixed frequency VAR models to obtain migration data at quarterly frequency. So we are interpolating or filling the blanks, filling the missing information about quarterly data when we only have annual information at our disposal. And then modeling panel vector autoregressions for groups of countries with similar migration and macroeconomic profiles. And the motivation for that is that we hope that the grouping of countries will help us overcome the shortness of the time series and the small sample issues. So why group that, and what is exactly the reasoning? So we start by observing that countries within Europe differ with respect to their migration profiles and differ in terms of the macroeconomic indicators and performance. The countries have different sizes, the country and the economies have different sizes. The migration flows come from different directions, also differ in terms of the patterns, the profiles. Context is very important because where do migrants come from or go to actually matters quite a lot. And this is another thing that varies strongly between countries. So taking this into consideration, we have grouped countries into 4 groups, broadly distinguishing the countries that had positive and negative net migration during the period from sort of the first 2 decades of the 21st century. But also for those with positive net migration, we looked at the level of income. So in this way, we obtained 4 groups: high positive net migration with high income, medium positive net migration and high income, then low positive net migration and medium income. And finally, in the 4th group, we are looking at countries that used to have negative net migration and low to medium income. The last group is mostly concentrated in Central and Eastern Europe, whereas the first, especially the first 2, is the old core of the European Union, so the EU 15 countries as they used to be before 2004. So data from the Quantum Estimates Explorer can be downloaded for any analytical purpose. As I said earlier, these are harmonized data, so brought to a common denominator, which is the United Nations standard definition of a 12-month duration of stay. The data are available for 32 countries in what we call the EU plus migration system, so the European Union, European Free Trade Association, and the United Kingdom. Plus we have also some data for North Macedonia and the residual category, rest of the world. And the data are grouped by sex and age in 5-year age groups, region of birth, and are available for years from 2002 to 2019. 2019, so with 18 data points. And the link to the data is on the slide. But for our purposes, we will be only looking at data for every country separately. We won't be looking at data on specific flows. So we will be looking at inflows, outflows, and net. So the difference between those for all the countries in our example. When it comes to the methodology, the first element, the multiple frequency VARs, is based on an idea published in 2015 by Schroffheider and Song, which is to apply a state space framework to estimate the missing values for those frequencies that we do not observe. So the idea here is that we take, if we say have series of annual as well as quarterly data, we can build a state space model, a state space vector autoregressive model, in which some of the observations will be observed at the quarterly frequencies, some other will be observed at the annually frequencies. And the state equation is the equation for the vector autoregressive model, which is written here in what was called this companion form. But what we observe is, as typical in a state space framework, what's called the observation equation. And the observation equation here is one where is based on a partition of the data into those parts that come at different frequencies. In our case, annual and quarterly. And this setup allows to take those values that come only at annual frequencies, include them in the model, but also at the same time allows for estimating those missing values for the quarters that haven't been observed. So in other words, this is taking the annual values and spreading them out over the frequencies which haven't been observed, so the quarters that haven't been observed. The second stage, so we use the first stage to estimate the missing quarters of the migration data. The second stage is use the estimate alongside with all the other variables that we already have available at the quarterly frequencies, and then use them in a Bayesian panel VAR framework for forecasting and calculating what are called the impulse response functions, so those functions that will be used for making scenarios. So we have big N countries, small N variables. We can look up to P lags, so lagged periods that we are regressing on from the past. And the model, when it comes to the ith country within a particular subset of the overall vector autoregression, has a form as on the slide. So the current value is a sum of weighted past values of all the vectors, where the weights come from the parameter matrix big psi, and then the model also includes a random disturbance term, which is in this case assumed to be multivariate normal with some covariance matrix sigma. And this is a Bayesian model, so we assume some default vague normal without prior specification. And the estimation and prediction of this model has been carried out in a toolbox that has been provided by the European Central Bank. The toolbox is called BAE, Bayesian Estimation, Analysis and Regression. And you can see the link to the toolbox on the slide as well. So now some results. We have carried out both in-sample and out-of-sample exercises. So for the in-sample forecasts, we left out 2 last years of migration data and we're trying to reproduce them based on what we knew. We produced conditional forecasts on the known trajectories of the other macroeconomic covariates. These examples are showing net migration, so-called rates. These are not proper demographic rates, but these are relative measures in relation to the population sizes. And the dotted lines indicate the mean and the mean forecasts and the 67%, so 2/3 predictive intervals. So it seems that for the last 2 years, for which we had harmonized data from the quantmic estimates, and unfortunately we didn't have harmonized data for the subsequent years according to the same methodology. It seems that the performance of the forecasting models was actually not too bad. The errors, depending on whichever error measure you might prefer, the root mean squared error, mean absolute error, or percentage error, there is some consistent picture emerging. There is, of course, we are talking about migration, which is quite an uncertain and volatile social process. So some errors are inevitable. Typically, net migration has higher errors than both immigration and emigration taken separately, which is again not surprising in the light of the demographic literature, because net migration is not a single process. It's a conflation of two processes, which may well act in different directions. So no wonder that uncertainty for that is larger. And we also looked at the coverage of the predictive interval. So we looked at if we had 67% predictive intervals, then on average we would expect the forecast to fall into them 67%, roughly 67% of the time. And actually, again, for some indicators and for some groups of countries, this coverage was quite good. So especially for group 3, we managed to get the immigration coverage nearly perfectly. And also for group 2, the performance for immigration and emigration wasn't too bad. And as before, for net migration, the differences between the actual coverage and the expected coverage was the largest, confirming the point about the problems with predictability of net migration being higher than in the case of either immigration or emigration. So we then carried out some other exercises. So we carried out of sample forecasts in the short term. So demographically short term is a few years. So we did look into forecasts until 2025, until the end of 2025. So 6 years ahead. And these were conditional on the various known trajectories of the covariates, of the macroeconomic covariates, which the information of which we already had available for longer than for migration, for the harmonized migration series. And we have also included some macroeconomic forecasts where we had them available. So you can see that these conditional forecasts follow the trajectories of the known and expected developments in the other covariates included in the VAR models, but the uncertainty of those is not too bad. It's something, especially within the horizon that we're looking at. The situation changes quite a lot once we move beyond the short-term horizon, and we also deviate from the trajectories of the covariates that we've observed. So this slide presents out of sample forecasts for the long term. The slides are showing forecasts until actually 2050, rather than 2025 as written here, and are unconditional, so are not conditioned on any observed trajectories. Instead, we are plotting whatever information is available on migration for 2018 and 19 as parts of the data series. So what is striking, of course, is how large the uncertainty can be, especially for some of the countries, especially for the countries that are undergoing migration transitions, such as many of those in the Central and Eastern Europe are. Final group of results concerns the scenarios. So we, in addition to forecasts, we looked at what are called impulse response functions. So the estimation of vector autoregressive models in one, where we look at different variables in one single model, allows us to assess the possible responses of different variables to changes in different variables within the models. So here we have for the 4 group of countries, we are showing impulse response functions which depict how much would a particular variable change if there would be a 1 standard deviation increase in immigration for groups 1, 2, and 3, or emigration for group 4. So in the dominant direction of migration. And for the 4th group, the responses are the response functions are inverted, just for the ease of comparison. So we can ask through that, by using these tools, we can ask the what if type questions. What if there is a rapid increase in migration? What if there is a rapid increase in wage premium or in unemployment? How would the other variables within those socioeconomic and migration systems react? So what lessons have we learned from this exercise? So as you have seen in the in-sample tables and graphs, as well as regarding those conditional forecasts in the short term, those forecasts have performed reasonably well. Immigration and emigration is somewhat better than net migration. Again, this confirms something that's been known in the literature about migration being much better predictable in the horizon of at the maximum a few years ahead. Again, as expected, the long-run uncertainty was very large. So this is something that we can only roughly approximate the uncertainty when we're talking about a horizon of a few decades ahead. And this is especially true for countries that are undergoing migration transitions, so changing their migration profile, such as those in contemporary Central Europe. When it comes to scenarios, there were some, again, not very surprising, but rather confirmatory findings in that immigration shocks, so rapid changes, increases in emigration, are expansionary to the economy, so it positively impact on the variables such as GDP, wages, and employment, whereas emigration shocks are contractionary, so act in the other direction. And the key finding here is that actually building these vector autoregressive models and estimating them based on some macroeconomic theories can help us examine the uncertainty of different migration and macroeconomic scenarios, also in the longer term, through the means of what-if type stress testing analysis. And what about the multiple frequency data? So what we found is that using mixed frequency models actually opened up a possibility for making more fine-grained analysis, because we could make fuller use of all the empirical information available both on migration and its drivers at different data frequencies. And this is something that we looked at macroeconomic data and migration data, so annual and quarterly data, but this is something that would be very important for even higher frequencies and for various non-traditional data forms, such as many of those being discussed at this conference in other sessions as well. So we can have very often situations where data come at different frequencies which may not necessarily align. The multiple frequency approach allows us to make the fullest possible use of the information all these different data sources contain by mapping the different data coming at different frequencies onto the so-called, we could call it a most frequent denominator. The more complex models, of course, could be used to get to make the most of the information. So we could look at models with finer spatial detail and finer temporal detail. We could look at other variables. The strength of the approach we proposed, especially in the panel VAR part of the study, is that we can do it, and we can help ourselves by allowing the borrowing of strength between different countries and different processes wherever this is feasible. And the work in progress. So we are currently finalizing the part of the work where we are looking at not only using data from the multiple frequency VAR in a Bayesian panel VAR as a two-step process, but we are looking at the ways of integrating these two steps so that also the uncertainty of the first step, the uncertainty of the multiple frequency imputation of data, is fully and formally propagated into the Bayesian panel VAR. The further details and the background to this study is available in a project report, and further details are available also on the QuantMIC project website. Thank you very much.